Alright guys, so welcome back to a new series of videos. This series is going to be about the MCAT, and we're going to be talking about general chemistry. So let's go ahead and get started. So before you even start chemistry, the first thing that you need to know is about the protons, electrons, and neutrons. Because if you don't know anything about these subatomic particles, then you won't be able to do anything in chemistry. Because chemistry relies on the relationship between protons, neutrons, and electrons, and how those affect everything. And let's start the discussion with protons. So protons are found in the nucleus along with neutrons. And protons have a mass of 1 atomic mass unit. Their atomic number is the number of protons found in the nucleus of the element. So if you go to the periodic table, the atomic number of hydrogen would be 1. And hydrogen has 1 proton in its nucleus. If you go to the periodic table again and search for sodium, let's say, sodium has 11 protons in its nucleus. So that's basically what a proton is, the atomic number of an atom. The fundamental unit of charge for both protons and electrons is 1.6 times 10 to the negative 19 coulombs. This is very important because this is one of the key things used in physics to determine the electrostatic relationships between two particles. Okay, neutrons, which means neutral, they don't have any charge, meaning they're neutral. Their mass is slightly higher than that of protons. However, the relative mass, since it's not a big of a difference, usually you will see that the protons and the neutrons have a mass of 1. If you see an element in the periodic table, what does the mass tell you about the number of protons and neutrons? So if you know that there are 6 protons in the nucleus of a carbon element, how do you calculate the number of neutrons? In isotope 12 of carbon, you have 6 protons, but you don't know how many neutrons do you have, and you want to find that out. You would just simply subtract 12 minus 6, and that'll give you the number of neutrons in the nucleus. So with that being said, 12 is the total mass of protons and neutrons. 6 is the protons, which is the same for all isotopes of carbon, and neutrons is the number that differs, okay? And I want to go over this because a lot of people don't know. The number below the atom in a periodic table is an average. So it's an average of all the masses of the isotopes of that particular atom, okay? That's why it's a decimal point. So isotope 14 of carbon does not have the same number of neutrons as isotope 12 of carbon. Isotope 14 of carbon has 6 protons, but it also has 8 neutrons. A carbon element has different isotopes, and each isotope has varying masses. And the same applies for any other element in the periodic table. So the general notation for isotopes would be X, which is the element, and it could be carbon, oxygen, bromine, chlorine, or any other element in the periodic table. Then on the top left corner, you would write the atomic mass of that element or isotope. In this case, if you have carbon 12, which is the isotope of carbon, you would write 12 in the upper left corner. So the symbol for atomic mass would be A. And then on the bottom left corner is the atomic number. So if you have carbon 12, we know that carbon has an atomic number of 6. So you'll write, instead of Z, you'll write 6. So this is how the general notation of an isotope works for any element. So electrons, they have a wider description, as you can see by all of this. And I will be going over that because really the main focus of organic chemistry is how electrons behave and how their behavior affects the reactivity of an atom, okay? So what are electrons? Electrons are what surrounds the nucleus of an atom. So in the nucleus, you have the protons and neutrons. Around the nucleus, you have the electrons. And electrons' reactivity varies with their levels relative to the nucleus. So you have the nucleus, right? The nucleus of an atom. Inside of the nucleus, we have our protons, and then we have our neutrons, right? Around the nucleus, you have shells that contain electrons. The closer the shell is to the nucleus, the lower in energy it is. The further away the shell is from the nucleus, the higher the energy it has. So, with it being very high in energy, it means that it's extremely reactive and it wants to interact with another atom. So an electron on the most outer shell, or the valence shell, usually wants to interact with an atom that is not itself. So an atom that's in the surrounding, it could be any atom, but it wants to interact with another atom that it's not itself. Okay, another key detail: if a proton is positively charged, an electron would be negatively charged. Always. Protons are always positively charged, electrons are always negatively charged. Neutrons, on the other hand, do not have a charge. They're neutral. They don't have a charge. Usually they'll denote electrons as so, because they have a negative charge. Protons will be denoted as, because they have a positive charge. If you put a proton and an electron, they attract each other, right? So due to this mass being so small, we don't use gravitational force to understand about the relationship. Instead, we use electrostatic force. Electrostatic force is a force between charged objects that can be an attractive or a repulsive force. And this varies depending on the charge of the object. So we talked about the mass of electrons relative to that of a proton. Now we need to talk about the mass of protons and electrons and how that affects the force between them. Since we all know that electrons and protons have very small masses, their gravitational force, or the force of attraction between their masses, is not as important as their electrostatic force. The electrostatic force is the force between two electrically charged objects that can be attractive or repulsive depending on the charge of the object. Okay, so if it's two protons, usually that's going to be repulsive. If it's two electrons, that's going to be repulsive. If it's a proton and an electron, then it's going to be attractive. Okay, so I already discussed about the reactivity of electrons that are further away from the nucleus, and I said they're usually favoring interactions between other atoms than interactions with their own nucleus. But I didn't mention what's the reason why they favor interactions with other atoms rather than their own nucleus. The reason why these electrons favor interactions with other atoms is because their nucleus does not have a strong pull on them, causing them to just loosely hang around in the outermost shell, or the valence shell, of the atom. And so this low electrostatic pull causes them to react with other atoms. And their reaction with other atoms is called a bond. Okay? If the atom has an equal number of electrons and protons, it is said to be neutral. However, if it doesn't, it means that it has a charge. Okay? If it has a positive charge, it's a cation. If it has a negative charge, it's an anion. And when an atom has a positive charge, it means that it lost electrons. When it has a negative charge, it means that it gained electrons, okay? Okay, so let's do an example together. In the question, it wants us to find the number of protons, neutrons, electrons that are in nickel 58 atom and nickel 60 plus 2 cation, okay? First, let's go to the periodic table and find nickel. And I see nickel over here, and nickel has a atomic number of 28. Okay, let me write that down. Nickel has an atomic number of 28 and a mass number of 58. Okay, and then nickel 60 has an atomic number of 28 again and a mass number of 60. So these two are isotopes of each other. So let's compare them. So nickel 58 has 28 protons. Nickel 60 also has 28 protons. Because remember, the number of protons does not change in an element or isotopes of an element. It's always the same. The only difference between different atoms of an element is the number of neutrons, which is the case for this example. Let's see. Nickel 58 has 58 minus 28, 30 neutrons. Let me just write that here. And then nickel 60 has 60 minus 28, which is 32 neutrons. Okay. And then let's find the number of electrons in both atoms. So remember, so the number of electrons is the same for atoms of an element unless there is a positive or a negative charge on different atoms, okay? So we know that nickel 60 has a +2 charge in addition to it being a different isotope than nickel 58. So let's work with that positive charge. Nickel 58 does not have a charge, so that means that it has 28 electrons. Now, nickel 60 has a +2 charge, so that means that we have 2 less electrons than nickel 58, okay? And remember how I said that the number of electrons and number of protons is equal unless there is a charge. So since there is a charge, we're just going to go ahead and subtract 2 minus 28, and that's going to give us 26 electrons. And why did I subtract? I subtracted because there is a positive charge. And remember, electrons are negatively charged. So when you're making an atom more positive, you're losing some of its negativity, right? And what causes that atom to be negative? It's electrons. So you're losing electrons. So nickel 60 with a +2 charge has 2 less electrons. And so we subtract 28 minus 2 to determine the number of electrons. And in this case, we have 26 electrons. And yeah, that is our final answer. I hope you guys learned from this video, and I'll see you in the next video.